Uh, Thursday, you should have done a little quiz and a DEUA. If you haven't, we'll catch you up eventually, but we have to forge our way forward into the next thing, which is polygons. Now, um, we're going to do our best with these notes, okay? But after this warm up. Now, look behind me on 211, perimeter and area. You should have done this and turned it in. And when I say done it, I mean on your own with your work. Okay, I keep getting funny business. So now, check it out. Monday, did you write no school? Because there was no school, right? Yesterday, if you didn't do the Schneider version of the warm up, you could write just Target Tuesday. If you didn't notice, it's not because I don't like y'all. It's not because I'm skipping. It's because I have to pull out other students to make sure that they're getting ready for the STAR test on Tuesdays. So Tuesdays, come in here, obedient and respectful to Mr. Schneider, please. Okay, now you would know from your notes or from the formula chart I gave you how to do area of a regular pentagon. Okay, so let's write this down. Pentagon, or another one is polygon. Okay, now how do we find the area of a polygon? Does anyone know the formula off the top of their head or from their notes? If I give you a formula chart, will you be able to find the area of a polygon? Okay, thank you. Theoretically, right? If you have the formula. So here's the formula. Okay, it is AP over 2. So watch this. Little a, big P over 2. Little a stands for apothem. Okay, apothem is from the center to a midpoint. Check it out right here. Center to the midpoint. This is called the apothem. Okay, so I'm going to put a equals 3 here. Now, P stands for what? What does your P usually stand for? Perimeter. So, looking at that picture, who thinks the perimeter is 8? It's part of the way, but remember, perimeter's all the way around. So 8 is just one little piece, right? So how many times would I put 8 all the way around? So if it's a pentagon, I should have 5 eighths. Now you can either draw the eighths or you can just in your mind do 8 times 5. Okay, so this is very important. Capital P is never going to be labeled on there. You got to, multiply it. So 8, 8, 8, you know, 8 eighths. 8 5 times, basically. 8 times 5 is 40. So again, the most common mistake is people doing 3 times 8. It's not that simple, unfortunately. Okay, you got to do a little step for the perimeter. So it's going to be apothem 3 times perimeter 40, and then divided by 2. You throw that into Desmos and you get 60, whatever the units are, squared. Okay, now here's some notes. I'm going to make this as short as I can. Every other geometry teacher is doing these notes, though. Again, I don't like doing stuff with staples. So, lo siento, mea culpa, no sé, no entiendo, etc., etc. Okay. Thank you, pen. Try to jump in. No. I had a fancy pencil once. Y'all know Mitsubishi? Like they make, what, cars? They also make mechanical pencils that sharpen themselves as you write. Isn't that cool? All right. Here we go. Here we go. Here we go. Here we go. Notes. All right. Polygons. Y'all heard this word before? Polygons. Okay. Polygon means many. What some people's teachers usually say. Polygons means many. Poly means many. Sides is gone. Many sides. Meaning 3 sides, 4 sides, 5 sides, 6 sides, all these different names of all these different shapes. However, polygon really means many angles, but either way, a polygon has at least 3 sides. It's closed, it's not open, it has no curves, and it is no intersecting lines. Okay, so here's an example of a pentagon. There's actually a government building called the Pentagon, which is literally a pentagon. Y'all familiar with stop signs? That's a polygon. And then this oblong looking thing over here. polygons have the same number of, let's write this down, sides and angles. Same number of sides, same number of angles, okay? And they're named by the number of sides. Wait, please. Now, sides and angles match. The sides tell you the name. So let's see how far we can do this. Three-sided figure, what do you call it? Triangle, easy, right? Four-sided figure, square is an example, quadrilateral. Now, square is correct. It's a specific version of a quadrilateral. Actually, I'm curious. In Spanish, how do you say four-sided figure? Do you know? Quadrago or something? No? See, my little son, I make him listen to Spanish kids songs, and they're like, quadrago, quadrago, quadrago. So I was like, I guess that's a quadrilateral. I learn things sometimes. Okay, now, here we go. Based on the table below, where n represents the number of sides, the sum of the interior angles represented by s can be found using this formula. Now, we're going to fill out this table first, and then we're going to fill in this big formula, okay? So, this formula is going to be, go ahead and write this, sum of interior. Here's a blank. And then we're also going to figure out each one, okay, interior. This will make sense hopefully later, just if I do my job, which I'm going to try, do my best. Except I cannot make a straight line. Hold on 1 second. That's the best I can do. Okay, now, let's fill out this table. Triangle, how many sides? This is too easy, right? 3 sides. Quadrilateral, 4 sides. Pentagon, 5 sides. Hexagon. By the way, y'all know pentagon is 5, like a, I don't know. What else has penta in it? Whatever. Hexagon, the way you can remember this one, hex has an X, so does the number 6. 6 and hex both have an X. Okay. 6-sided. Now it gets weird after that because it says what? Heptagon, 7. Octagon. Sounds like octopus, 8. Nonagon. It kind of sounds like 9. 9. Okay, nonagon. Decagon. Hopefully you know that a decade is 10 years. 10-sided. Now, this is not a trick question. How many triangles are in a triangle? One triangle means one triangle, right? Okay. Now, look at these pictures. You can see the dashed line that's cutting it. When you cut a diagonal, it makes this into 2 triangles, right? Then on this one, you can see it cuts into 3 triangles. And you see the pattern forming here, right? As you add sides, you add the number of triangles on the inside. So fill this out, please. Okay, now, the sum of the interior. This is stuff we learned, well, maybe middle school, but we talked about it this year. How many degrees are in a triangle? 180 degrees. Everybody, you want to, like, right now, know this. A triangle is 180 degrees. If you didn't know that, gotta know it, okay? So, go ahead and write, one triangle is 180. So, guess what we do if there's 2 triangles? 180 times 2, right? So 180 times 2, mental calculator or Desmos calculator. I'm just going to cut to the chase with the numbers here. 360, okay? 1 times 180. 2 times 180, right? That's kind of what we're doing here. 3 times 180 gives you 540. 4 times 180 gives you 720. 5 times 180 gives you 900. Okay. 6 times 180 gives you 1080. That's 3 full spins. Okay. Like Winter Games, 3 spins. 1080. Okay, and then 7 gives you 1260, and then 1440 for 8. Now it keeps going on and on, but there's a pattern here, okay? I want us to think from left to right. How did we go from the number of sides to the sum of the interior? So, what did I do to the number of sides to get to the next column? How did I get from 3 down to 1? What did I have to do? Like, what's the difference between each of these numbers right here? Yeah, you're just subtracting how much? Minus 2. So, to get a formula here, first thing we did was n minus 2. And then, what did we do all the way down to get the sum? And I wrote it here. What did we do? Multiply by a triangle, which is 180. So times 180. So we just found the sum of interior angles formula is n minus 2 times 180. So write this down here at the top. Okay. Now, one other thing we're going to write here, because there's, for some reason, these notes don't have a space for it later. If you have a regular polygon and you want to find just one angle on the inside, you're going to do this same thing, find the sum, but then you divide it by the number of sides, okay? So this is going to be an ugly fraction. Try to fit it in here, okay? It's n minus 2 times 180 on the top, but you have to divide by n on the bottom, divided by n. Okay, let me zoom in a little. Hopefully that's visible. N minus 2 times 180 divided by n. This ugly fraction is how you find one interior angle of a regular polygon, okay? And with that said, flip it over to page 2. We're going to, back to this front page, we're going to do some examples, try to make it painless here, okay? Anyone still getting this? Okay. Again, if you need anything on that table, for the next page here. Please, please. Okay. Good. Next page. Now, it says, find the sum of the measure of the interior angles. So look for this keyword. When you see the word sum, okay, and then interior, we just wrote this down. I'm going to write it right down. Write it here again. N minus 2 times 180. Okay. What does n stand for? Number of sides. Now look, we talked about some of these names, but look at these names. This is kind of weird. 15 gon? What's a 15 gon? Well, guess how many sides are in a 15 gon? 15. Okay, yeah. So it's in the name. A 21 gon is, imagine 21 sides. 48 gon, 48 sides. 36 gon, 36 sides. Okay? It's hard to imagine so many little tiny sides, but they exist theoretically. So let me show you how you do this. Take that number, that's your n, and do n minus 2 times 180. So let's just set up the formulas. 15 minus 2 times 180. Let's do b. 21 minus 2 times 180. 48 minus 2 times 180. 36 minus 2 times 180. Now this becomes calculator. Just throw it in, okay? All right, so here we go. Let's do all 4 of these real quick, okay? So 15 minus 2 times 180. Do you see how I typed this in? And then 21 minus 2 times 180. I'm trying to edit those. Say again? I need you here for this. Assuming there's time. We'll get through this. We should have time. Now look, you type it all in, you get your sums. So it's kind of weird to think about. If it's a 15-sided figure, all the inside angles add up to 2340, 2,340. Okay? 21 sides adds up to 3,420. Sorry, it's kind of tiny. 8,280. Okay, so there they are. All right, now that's it. Example 2. This is where people get off the train. And you stay locked in, okay? This is the application, okay? It doesn't say find the sum of the interior. It says find x. Found it. Anyways, so what we need to know is what do these four angles add up to? If I know what these add up to, I can make an equation. I can solve an equation. So what do these four add up to? To find the sum, like there's four sides here, right? 1, 2, 3, 4. N equals 4. So if I want to find the sum of those four sides, it's going to be just like above, 4 minus 2 times 180. Now, if you type it into Desmos, I'm going to tell you what it gives you. It's 360. And that is something you are always allowed to memorize things. I think it would be a good idea. Every four-sided figure adds up to 360, right? Like I want you to memorize a triangle, 3 sides is 180. So I think it'd be a good idea. 4 sides adds up to 360, right? Hey, you good? All right. Now, here's what you're going to do. When you have 4 angles, one of them's x, this is the way you knock it out. You're going to make an equation adding up these 4 things. X plus 134 plus 73 plus 82 equals, these 4 add up to, and then here's the question. What do these 4 add up to? Well, that's why we found the sum. It's 360. I really want to emphasize this. Whenever you're setting up an equation, this number right here depends on the number of sides. Okay? So, how do I solve this? Okay? Whenever you have a big, long equation, you want to combine any like terms, and I see 3 like terms. On this left side, I got this number, and this number, and this number. So I can combine all 3 of these. If you add all these up, you give 289. All right. And then last step, if I'm trying to get x by itself, how do I get rid of a plus 289? What's the opposite? Minus 289, and I get 71. 71 degrees. Okay. So you're going to be asked to do problems like this. Do you see how you need to find the sum first, make an equation, combine like terms, solve for x? That's your missing piece. Okay. All right, halfway done. Let's talk about exterior angles. Does anyone still need example 2? Hey, put that away. Do you need example 2 or no? Good? Okay. Look at this table. Now, we already talked about inside, interior. Now we're going to talk about outside, which is called exterior. Okay. Now, let's fill this in. Measure of one interior angle. So we already did stuff like this earlier. Okay. But inside of a triangle, we know it's 180 divided by the number of sides 3. That gives us 60. The sum of a 4-sided figure is 360 divided by the number of sides 4. That gives you 90. 5-sided figure is sum is 540 divided by the number of sides 5 gives you 108. And then 6-sided figure is 720 divided by the number of sides 6 gives you 120. Okay. I know I did that kind of fast, but that's taking the sum divided by the number of sides. That will give you one interior of a regular. Okay. Now, how do you find one exterior angle? Okay. So over here, we're gonna make some equations here that we got to remember. Okay. So the sum of the exterior of every polygon is always, keyword, always 360. Okay? So is everyone writing this down? The sum of the exterior of every single polygon, and they always add up to 360, right? Now look, one exterior. To get one exterior, you can find the supplement of each interior, okay? And 180 minus this gives you 120. 180 minus this gives you 90. 180 minus this gives you 72. 180 minus this gives you 60, okay? But I'm going to tell you another way. Each one or a exterior, and it has to be of a regular polygon, is going to be 360 divided by the number of sides. 360 divided by n, okay? That is another way to get one exterior angle, okay? Now we can fill these in. Number of sides is 3, 4, 5, 6 here. So if you take that one exterior times the number of sides, 120 times 3, 360. Okay? 90 times 4, 360. 72 times 5, 360. 60 times 6, 360. Do you see how the sum of the exterior is always 360? Okay? I want you to see how we get these numbers from the formula. Okay. And here's the deal. When you add up the one in and the one out, these two columns, if you add up this and this column, they always add up to 180, okay? Because they're supplementary. 60, 120, 180. 90, 90, 180. 108, 72, 180. 120, 160, 180. You're just adding up the one interior, the one exterior, one exterior, okay? Now, I got to show you some examples. We'll be done. Flip it over. I know this is a lot, okay? I would not have done this in one day, but all the other geometry teachers wanted to do it. Here we are, working as a team, I guess. So, ready? We'll do this fast. What shape is this? First of all, it's regular and it's octagon. N equals 8, right? What are we looking for? Each interior. Let me remind you where we wrote that down. Right here on the right side, okay? Each interior. It's this ugly fraction, n minus 2 times 180 divided by n. So let's do that, okay? So each interior, n minus 2 times 180 divided by n, is going to be 8 minus 2 times 180 divided by 8. All right, 8 minus 2 times 180 divided by 8. Okay, so when you see each interior of a regular polygon, you got to use that formula. We're just going to knock that out real quick. Look. 135, okay? So I found 135 as my... Now, by the way, it'll say each interior, or it could say one interior. Same thing. Each, one. And we got what, 135? I've already forgot. Yeah, 135 degrees. Now, one exterior or each exterior, it all means the same thing. That formula let me just scroll up real quick, is right here. One exterior, or each exterior is 360 divided by n. So that's all you got to do. 360 divided by 8 gives you 45. Yes, 45 degrees. Okay. So, given that 60 degrees is the measure of an exterior angle, okay? Now, these are going to be a little bit more spicy, so let me show you how to do it. Actually, yeah, why not? If this is the exterior angle, okay, 60 degrees is exterior angle of regular. Exterior is 360 over n, okay? 360 divided by what gives you 60? If you remember what we learned during trig is that there's a switcheroo rule. You can just do n on the left, 360 stays on the top, 60 goes to the bottom. You do the math, you get 6, okay? Okay. Oops. That's pretty much it. This next one's kind of, I don't know. I'll write it down so you have it. But for each interior, or an, which means one, or each, okay, same thing. That formula is n minus 2 times 180 divided by n, and that's supposed to equal 150 degrees. Now, I don't think you're going to see a problem like this. I'm still just going to fill it out so we have our notes done. But if you had an ugly fraction equals this number, you have to get rid of that denominator. You multiply by n. Cancel that out. Distribute the 180, so you get 180n minus 360 equals 150n. And then you want to move this to the other side, move this to the other side, so you can do 2 steps in one. Add 360, subtract 150n. You get what? 30n equals 360, and then you can just divide 360 by 30. All that to say you should get 12. Like I said, that's ugly. I don't think you're going to have a problem like that. There it is on the notes anyways. Last thing we should have started with is the types of polygons. So you got to know convex and concave. Okay? So if you just look at them, you can kind of figure this out. Convex, do you see how all the corners are poked out? Poked out, poked out, poked out. Concave, do you see how we have one poked in? Or you could say it's caved in. Caved in. Okay, so if it caves in, concave. No cave, convex. Regular means all the sides and angles are equal. Irregular is not. So keep that. Assignment tomorrow. Y'all have been great. This is the best second period I've ever had in 2026. Don't let anyone tell you otherwise. I said in 2026.